Hey everyone, ready to dive into a cosmic mystery that had astronomers scratching their heads for years. We're talking about a star not too far away in the grand scheme of things, about 190 light years away, called the Methuselah star.
You might also know it as HD 140283. And yeah, it's a pretty wild one.
And it's not even about how big or bright it is, it's all about its age. See, this star, it seemed to be older than time itself, like older than the universe is even supposed to be, if you go by that whole Big Bang theory. It was a real head scratcher.
Yeah, the first estimates, they pointed to a jaw-dropping 16 billion years. And well, we all know the universe is only about, what, 13.8 billion years old, give or take?
Yeah.
So you can see how we had ourselves a bit of a cosmic paradox.
Talk about a paradox, right? Like finding a birthday card that says happy 16th birthday when you haven't even hit your teens yet. So how do astronomers even begin to tackle this? It's not like they could just carbon date the Methuselah star.
Well, they started with what they could see its light. Specifically, how much of that light gets absorbed by different elements hanging out in the star's atmosphere. That's how we figure out what a star is made of, its composition.
So like taking a cosmic fingerprint of the star. But how does that tell us how old it is? I'm a little lost.
It's all about the heavy elements, or should I say the lack of them. See, the early universe, it was pretty basic, mostly hydrogen and helium, the simplest elements. It wasn't until later on that stars started creating heavier stuff, carbon, oxygen, iron, the ingredients for, well, us, and everything else we see.
Wait, so the carbon in my coffee cup, the iron in my blood, that was all made inside a star. That's kind of mind-blowing.
It really is. What's even cooler is that we can trace this cosmic family tree just by looking at what stars are made of. Take our sun, for example. It's pretty young, relatively speaking, about 4.6 billion years old. It's got a higher amount of these heavier elements, kind of like the universe's trust fund kids, formed from the leftovers of older stars.
And the Methuselah star, more like the strong, silent type.
Exactly. Incredibly low and heavy elements. Tells us it must have formed way back when, before a lot of those older stars had a chance to spread their ashes, so to speak. It's like finding a pristine first edition comic book from the dawn of time.
Okay, so low metal content equals old age.
You got it.
But how did they go from really, really old to older than the universals? That's where things get a little tricky, right?
Now that's the billion-dollar question, isn't it? I mean, saying a star is old, that's one thing, but saying it's older than the universe itself, that's a whole other ballgame. And it all boils down to how we actually measure a star's age. And believe it or not, it's a lot trickier than you might think.
I'll be honest, I kind of pictured a giant cosmic calendar somewhere with stars and their birthdays all neatly marked down. I guess it's not that easy, huh?
Not quite, no. It's more like trying to figure out how old a tree is after it's been turned into a beautiful dining table.
Yeah.
You can't just count the rings anymore. We have to rely on other clues and, of course, a lot of math.
So what clues are we talking about here?
Imagine you're looking at a light bulb. You can tell if it's bright or dim, right? But to really know how much light it's giving off its luminosity, you need to know how far away it is. Because a dim bulb up close can look just as bright as a powerful one that's far away. Same goes for stars.
Okay, so distance is key. But how do you even measure the distance to something that's like trillions and trillions of miles away?
That's where things get really clever. Astronomers, they've got some tricks up their sleeves. And one of the most important ones is something called parallax.
Parallax? Wait, isn't that like something to do with 3D vision?
Exactly. Hold your finger out in front of you and close one eye, then the other. See how your finger seems to jump a little bit against the background? That's parallax, the way something appears to move when you view it from different spots.
Right, though I'm guessing we're not talking about winking at stars here.
Not exactly, no. We use the Earth's orbit around the sun. By watching a star from opposite sides of our orbit, 6 months apart, we can measure how much it appears to shift its position against the really distant stars way in the background. It's like knowing the distance between your eyes helps your brain judge how far away your finger is. Knowing how big the Earth's orbit is helps us calculate how far away a star is.
Wow, that's incredible. So we've got distance. What else do we need to figure out this age thing?
Well, along with distance and luminosity, we also look at a star's mass and what it's made of its composition. Once we've got a handle on those, we compare them to models of stellar evolution. Basically, they're like computer simulations of how stars are born, how they live, and how they die, all based on the laws of physics.
So it's like matching a suspect's fingerprints to a database, but instead of criminals, we're trying to pin down the age of a star.
You got it. And in the Methuselah star's case, you see, those initial measurements, As amazing as they were for the time, well, there was enough wiggle room, enough uncertainty that its age kept coming out older than the universe. It was a real puzzle.
I bet. So what did astronomers do? Just give up, throw in the towel?
Absolutely not. It was like a detective story, and they weren't about to close the case without cracking it wide open. They knew that to really solve the Methuselah star mystery, they needed even more precise measurements. And that's where the Hubble Space Telescope enters the scene.
Hubble, the ultimate cosmic detective. What did it manage to dig up? Hubble swoops in to save the day. I can already see the headlines now. Space telescope cracks ancient star case. But how did Hubble actually help out? How to get those measurements to be more accurate?
Well, remember how we talked about parallax
Mm-hmm.
and using the Earth's movement to see how stars shift? The more precisely we can measure those tiny shifts, the more accurate our distance estimate is going to be. And that's really where Hubble shines, so to speak. Up above the Earth's atmosphere, no pesky air to blur things. It's like the difference between looking through a crystal clear window and, well, looking through a fish tank.
Okay, so Hubble gets a much clearer view from up there in space.
Exactly. And with that super clear view, Hubble managed to nail down the Methuselah star's distance way more accurately than ever before. And that led to, you guessed it, a new age estimate, 14.46 billion years old.
Still older than the universe, but getting closer.
Oh, much closer. And remember, this new estimate still has a bit of wiggle room, a margin of error, just like any good scientific measurement should. In this case, that margin of error was about 800 million years, so there was still a chance, even if it was a small one, that the star's actual age could fall within the universe's 13.8 billion year lifespan.
Okay, so it's a real nail biter. Did those 800 million years make all the difference? Did the Methuselah star get to stay in the cosmic club?
It did. In 2021, even more precise measurements and analysis came in. They even looked at the star's oscillations, which are like tiny vibrations, to learn about its insides and really fine-tune its age. And those studies, well, they put the Methuselah star firmly between 12 and 14 billion years old.
Officially old, but not breaking any cosmic rules anymore. What a relief.
Right. And while our Methuselah star might not be older than the universe itself, it's still a total rock star. Literally from a time when the universe was just a baby. Just imagine the stories it could tell.
I know, right? It's like finding a message in a bottle, except that bottle has been floating in the cosmic ocean for billions of years. What can this super old star tell us about the early universe that we wouldn't know otherwise?
For one thing, it gives us a peek into what those very first stars were like. The fact that the Methuselah star is so low in heavy elements, well, it tells us it formed in a very different neighborhood than stars forming today. Back then, the universe was kind of like a bare-bones grocery store. There not a lot of those heavier elements to go around, so those first stars were probably massive, lived fast, and died young, and were totally different from our own sun.
Wow, that's wild. So by studying just this one star, we're actually learning about a whole era of the universe's past, long before our sun even entered the scene. It's like getting a glimpse into a lost world.
Exactly, and it really drives home the point that the universe we see today with all its awesome galaxies and stars didn't just magically appear out of thin air. It's been billions of years in the making, constantly changing and transforming, and it's still going.
The Methuselah star is a great reminder that we're still just scratching the surface when it comes to understanding the universe and its crazy long history. It makes you wonder what else is out there, right? I mean, we've got the James Webb Space Telescope out there now, looking further back in time than ever before. Who knows what else we might find? Maybe an even older star, one that really throws a wrench in our understanding of, well, everything. Or hey, maybe the Methuselah star still has a few more surprises up its sleeve. I guess only time will tell.
That's the beauty of science, isn't it? There's always more to learn, more to uncover, and for every answer we find, it feels like a dozen new questions pop up.
So true. Well, on that note, I think it's time to wrap up our deep dive into the amazing story of the Methuselah star. It's one ancient star with one incredible story. A good reminder that the universe is full of surprises. Its history is way more interesting than we probably realize, and we're lucky enough to be here to try to figure it all out one star at a time. Thanks for joining us, everyone, and until next time, keep looking up and never stop asking those big questions.